I'm going to study about the velocity of particle in S section. Concentrate, okay? This is T is equal to 0, T is equal to T by 4, T is equal to T by 2, T is equal to 3T by 4, and T is equal to capital T. Right. Here I'm going to take velocity of the particle in terms of cos omega t. So velocity of the particle is A omega into cos omega t, correct? Or can I write it as A omega into cos of, how can you write omega in terms of 2 pi and capital T? It is 2 pi by capital T into T. Guys, is there any doubt? I hope it is clear, right?
I have a
But
doubt,
if you want to, yeah, tell me.
Sir, why you converted only that 1 omega, sir? In A omega, omega is the same, but in cos omega t you converted.
Yeah, because I have T in small t in terms of capital T. No, see. You will understand it. Wait for 2 minutes, you will understand. Okay. If I substitute T is equal to 0, what will be the velocity of the particle at that instant?
0.
There. Is it 0? Where will you substitute T? T
A
is small
omega,
t.
sir.
It will be A omega, no? Because cos 0 is 1.
Okay, sorry, sir.
It is A omega, correct? Now, if I substitute T is equal to capital T by 4. So, which expression is suggested for you? Will you substitute capital T by 4 in the first one or second one?
Second one, sir.
Second one is more advisable, right? Because T will get cancelled, you will get in terms of pi by 2. That is why there I changed it in terms of 2 pi by 2. Okay. Now, what will you get?
I think 0, sir.
Don't think. Solve and tell me. So, you will have cos of 2 pi by capital T into T by 4. Capital T and
Zero
capital
only,
T
sir.
are
Cos 90, sir.
just cos pi by 2. Cos pi by 2 is 0. Then what about T by 2?
-1, sir.
Minus
1.
A omega.
Sir, that only, sir. Cos pi is -1, I said, sir.
Cos pi is -1. So, minus A omega. Tell me in terms of A omega. 3T by 4.
Minus A omega by √2.
See, it will be A omega into cos 3 pi by 2.
Sir.
A omega into cos of 2 pi by T into 3T by 4. 2 and 2 will get cancelled. T and T are gone. 3 pi by 2. 3 pi by 2 is also 0. Cos 3 pi by 2 is 0. So 0. At T is equal to capital T, what will happen? Again, it will become A omega. Means the cycle will repeat itself. Are you able to understand?
So, in positive negative cycle, sir.
Cos 3 by 4 is not -1 by √2, sir.
3T by 4 and you have a 2 pi here. 2 and 4 will get
No,
cancelled.
sir. 3 pi by 4 only you took, no, sir, now.
Cos 2 pi by capital T into 3T by 4. T cancels. You didn't cancel this. That is why you got 3 pi by. You will not get √2 in this expression at all. So you'll either get A omega minus A omega. These are the expressions that you're going to get. So what this is trying to tell us is what this equation is trying to tell us is when the particle is at mean position at t is equal to 0, it has a maximum velocity of a omega provided it is moving towards the rightward direction. Right? So at the extreme position, what is going to happen? That's what I told you. O to A is 1/4 of the cycle. So this is the point where it is going to be a t by 4. Are you guys able to connect all the dots? So what I'm trying to do here is I'm trying to speak in terms of time. I'm also trying to speak in terms of displacement. Okay. So t by 4 is the time taken for the particle to go from mean position to the first extreme position. So at extreme position, what should happen to the particle? It should come to momentary rest for its direction to be changed. Correct?
Yes, sir.
Again, what will happen is, see, when the particle is going from O to A, is it accelerating or retarding? Again, the same question. When it is going from O to A, velocity of the particle is to the right, acceleration of the particle is to the left. Because in a simple harmonic motion, it is always directed towards its mean position. So going from O to A, the particle is, complete the statement, particle is dash, retarding or accelerating?
It's accelerating, sir.
O to A, O to A. Look at the way the arrow marks are.
Retarding, sir.
It is retardation. Whereas when the particle comes back from A to O, is it accelerating or retarding?
Accelerating.
It is accelerating because when it is coming from A to O, velocity of the particle is to the left, acceleration of the particle is also to the left. That is why if you see, when it is coming, so at point A, it is momentary, it is at rest. So from A, when it is coming to point O, what is happening is it is attaining the maximum velocity at the mean position, but in the opposite direction. That is why it is minus a omega. Okay. Again, when it is going from O to B, what is happening to the particle? The velocity of the particle is in this direction. Acceleration is in the opposite direction. Again, simple harmonic motion definition. From O to B, acceleration is always, whether it is from O to B or B to O, acceleration is always towards the center. Right. Again, it is retarding. That is why from O to B, its velocity is decreasing and it is becoming 0. Again, from B to O, it is becoming max. You're able to understand how the cycle is running?
Yes, sir.
So this is the meaning. So what, in terms of question, how they will frame is, they will ask you what is the velocity of the particle at 3t by 2. Will you be able to solve this? Suppose I have to frame a question. There is a particle which is in simple harmonic motion whose displacement equation is a sin omega t. Find velocity of particle at t is equal to 3t by 2. Will you be able to find it? So for a particle whose displacement is
formula, right, sir?
What formula will you use? Velocity of the particle is
t by 2 pi by
a
t.
omega cos, yes, a omega cos omega t. Okay, you should remember this expression for you to substitute first. So a omega into cos of 2 pi by capital T into t. So in the place of t, you're going to substitute this. So what will you get? A omega into cos of 2 pi by capital T into 3t divided by 2. 2 and 2 will get cancelled. T and t is gone. So you'll get a omega into cos 3 pi. Cos 3 pi is minus 1. So minus a omega is the answer. That is exactly after 1.5 time periods. Are you able to understand?
Yes, sir.
Okay. So one small trick that I'm going to explain you is be careful about it. Okay. Be careful with this particular point. If they give y is equal to a sin omega t, then the velocity of the particle is a omega cos omega t. Suppose they give you the question as x is equal to a cos omega t. If the displacement is defined in terms of cos, then what will be its velocity? Can you please derive it? I just want to check if you have understood. So if I need the velocity of the particle, I need to do an instantaneous value. So I need to differentiate it. Dx by dt is going to give me what? A omega into, sorry, not A omega,
minus
A into d by dt of cos omega t. You have learned differentiation. A into derivative of cos.
minus sign.
Very good. Minus sine omega t into d by dt of how much?
Omega t.
That's it. So that will be minus a omega sine omega t. Okay. So you need to be very, very, very careful about this. So depending on what expression they are giving, you need to calculate its velocity. Okay. For example, had the question been x is equal to a cos omega t, find the velocity of the particle at 3t by 2, then what your answer will be? Velocity of the particle is minus a omega into sine of, in the place of omega, I should write it as?
2 pi by t.
Very good. 2 pi by t into t. So at t is equal to 3t by 2. I take it and substitute it here. What will I get? Minus a omega into sine of 2 pi by capital T into 3t divided by 2. Answer? Minus a omega sine 0. It's a 0.
0.
Means the particle initially is at, the particle at time 3 is equal to 3t by 2. It is at momentary rest. I hope it is clear.